So what do your text editor's undo button and a massive globe-spanning task queue possibly have in common? Well, it turns out they're both powered by the exact same elegant, surprisingly simple idea. It's a design pattern that's all about packaging up an action and then deciding what to do with it later. Today, we are going to unpack the command pattern.
All right, let's start with a metaphor that makes this crystal clear. Think about a delivery service. The driver doesn't care, not one bit, if the box has a book or a phone inside. Their job is to handle the package. They queue it up, they route it, they deliver it. It's the recipient who finally opens the box and acts on whatever's inside. And that, right there, is the core idea of the command pattern. We package an action into an object, completely decoupling the part of our system that requests the action from the part that ultimately executes it.
So that leads to the big question, right? Why go to all this trouble? I mean, in programming, our first instinct is usually just to call a function directly. Why add this whole extra layer of packaging the action at all? What problem is this actually solving for us?
Well, the need becomes incredibly obvious the second you hit this very common problem. What if you can't, or maybe you just don't want to, execute an action immediately? What if you need to run it later, or on a totally different server, or maybe as part of a big batch job? See, direct function calls, they just fall apart in those scenarios.
But by turning an action into its own self-contained object, a command, we suddenly unlock this whole world of amazing possibilities. You want to queue up tasks? Easy. Just put the objects in a list. You need undo-redo functionality? Just add an undo method to that object. Every command you store becomes a perfect built-in audit log. You can serialize that object and send it clear across a network, or even scheduled to run, next Tuesday. These aren't just nice-to-haves. These are the absolute building blocks of modern, scalable software.
Okay, so that's the why. Now let's get into the how. Let's pull up the blueprint and see what this actually looks like when you write it in Go.
The pattern really has 4 key players. First up, you've got the command interface. Think of this as the contract, the shipping label that says, hey, this box is a deliverable action. Second is the concrete command. That's the actual item in the box. Third, we have the invoker. This is our delivery driver, the one who holds onto the packages and decides when to deliver them. And finally, you have the receiver. That's the destination, the system that actually opens the box and does the real work.
Now let's look at the classic flavor of this pattern. Here, our command interface is super simple. It just has one method: execute. In Go, this is incredibly powerful. Why? Because any object from any package that happens to have an execute method automatically satisfies this interface and becomes a command. There's no ceremony, no implements keyword. It's just clean, structural, and really elegant. And here is a perfect example of an invoker, a command queue. Just look at how simple this concept is. Under the hood, it's basically just a list that holds our command objects. As new commands come in, they're just appended to that list. The queue just sits there collecting these packages until some condition is met, maybe the queue hits a certain size or a timer goes off, and only then does it loop through and execute the entire batch. And this is the result. It's kind of wild to see in action. The first couple of commands get added to the queue, and nothing. Crickets. Complete silence. The sender, our main function, has totally relinquished control. It's only when that final command is added, the one that triggers the batch, that all the messages suddenly print out at once. The invoker is in charge of the timing, not the sender. That is deferred execution in action.
Okay, but we can take this idea even further. So far, we've treated commands as just pure actions. But what if they could also be powerful carriers of data and context? This is where it gets really interesting.
This brings us to a second really common flavor of the pattern. Instead of an execute method, our interface has an info method. Now, the command isn't the action itself, it's a package of data. The receiver takes this package, calls info to see what's inside, and then it decides what to do. This maps perfectly back to our delivery metaphor. We're finally opening the box to inspect the contents.
Check this out. We can have a command that actually captures the exact time it was created. Then, a full second later, when a receiver finally gets around to processing it, the command can still report exactly how much time has passed since its own birth. It carries its own history with it. This right here is the absolute core of systems built on event sourcing, where instead of just storing the current state of the world, you store a log of every single command or event that ever happened, each one carrying the full context of the moment it was born.
And what's cool is you can start combining these patterns in really fascinating ways. Here, we've got a command object being passed down a chain of responsibility. Just imagine a package moving along a conveyor belt, going through different processing stations. Each station, our logger in this case, can inspect the package by calling its info method, maybe it adds a stamp or a sticker, and then it just passes it along to the next one, all without ever being the one to perform the final delivery.
All right, now there's a really critical distinction we have to make here. It is absolutely vital to separate the command pattern from a very similar-looking one called strategy. Honestly, confusing these two is probably the single most common conceptual mistake people make.
So the difference really just boils down to this. Strategy is all about how to do something. You've got one goal, like sorting a list, and multiple algorithms to achieve it. Quick sort, merge sort, whatever. They are interchangeable ways of doing the same thing. Command, on the other hand, is all about what to do. It encapsulates lots of different independent actions. Create a user, delete a post, process a payment. These are not interchangeable. They are fundamentally different outcomes.
Okay, so we've seen the metaphor, we've seen the blueprint in code. Now it's time for the revelation. Let's see how this simple idea of packaging an action into an object powers some of the most massive, real-world systems you probably use every single day.
Let's start with a classic. How do you build an undo system? Well, with this pattern, it's almost laughably simple. You just add an undo method to your command interface. Now, every action a user performs is just an object you push onto a stack. To undo, you just pop the last command off the stack and call its undo method. And just like that, you get a complete, robust undo-redo system pretty much for free.
And this is where the design of Go just brilliantly embraces this whole pattern. I mean, what is a Go channel, really? It's a queue for passing messages between concurrent processes. So a chan command is thread-safe, it can be buffered, and it totally decouples the sender from the receiver. It is, quite simply, one of the most natural command invokers ever designed, and it's built right into the language.
And here it is. This is the big aha moment. If you've ever worked with modern distributed systems, I guarantee you have been using this pattern all along, you just maybe didn't know the name. Every single message in a Kafka topic is a command object. Every event in a DynamoDB stream is a command. They are all just self-contained packages of action and context sent by a producer and consumed by a receiver, often much, much later and on a completely different machine.
And this isn't just some abstract theory. The biggest names in distributed task queues, we're talking systems like Temporal, Celery, and cloud services like AWS Simple Queue Service, are all fundamentally built on this pattern. At their very core, they are just incredibly sophisticated, massive-scale command invokers.
Now, before you run off and start wrapping every single function call on a command object, it is really important to know the rules of the road and the common anti-patterns that you need to watch out for.
First, try to avoid making your commands too small. If you don't actually need queuing or undo, just call the function directly. It's simpler. Second, your commands should only carry serializable data, not live resources like a database connection. That's a recipe for disaster. Third, always double-check that you aren't accidentally implementing the strategy pattern when you mean to use command. And finally, and this is so crucial for any real system, your execute method absolutely has to be able to return an error, otherwise failures are just going to get swallowed silently.
And that really brings us to the ultimate takeaway here. The command pattern gives us the simple but incredibly powerful vocabulary for building really complex systems. You package the action, you transport the package, and then you execute it at the right time, in the right place, by the right receiver. This isn't just another design pattern. This is fundamentally how modern distributed systems are built.